Knock it off. Abbott and Costello, Murray and Vader. Enough. Knock it off. Just for 1 minute. G'day guys, Matt from Hal Heavy Duty. We're an Aussie machine shop that specialises in the drilling industry, and today we're sticking some O-ring grooves into a large water swivel. I'm going to be using the Hulk, which is our 11-ton Spanish Megabore, to get the job done, which is great because we can just stuff stuff in it. We can just put stuff up the bore, which saves a lot of time. Now, we are going to be using both a face grooving tool, and we're going to have to cut a 45-degree internal O-ring groove, and I'll show you how we do it. Look, this job is pretty simple, and in a little lathe, I could probably do this in 15 minutes. It's just because it's relatively gigantic, it takes a bit longer. Now there's two kinds of O-ring grooves, static and dynamic. We are going to be putting in two different static O-ring grooves, meaning that once the O-ring is seated, it doesn't move. Between the bolt hole you can see there and the relief groove, we're going to have to put a little O-ring groove in there simply to stop water leaking. This is a component from a gigantic water swivel, and on the inside here, the only place we can put it is to actually chamfer that out. Now we're going to do the face groove first, so what I want to do here is stick the part into the lathe and then get some measurements and see, can we use an off-the-shelf O-ring? If not, we'll have to make one up, which isn't really a drama with static O-rings, more difficult, and I wouldn't personally like doing it with dynamic O-rings because the movement will just cause them to break, but once it's locked in there for a static O-ring, it's fine. Tooling wise, we're going to be using an ISCAR face grooving tool. We have 3 of these in the shop for varying sizes, small, medium and large. This will be the large one. I'll be using our little O-ring handbook. Most manufacturers of O-rings have these. This is just for the ones that we use, so that we can calculate out groove width, groove depth, see if there's something available off the shelf, and if not, we'll just make one up or pick the best spot for it. So let's do that now. I'm pretty sure we're not going to find one off the shelf that will suit, but we might just get lucky. This has been named by someone in the comments Excalibur. It's about a meter long set of caliper or verniers, but we're just going to use the little middle-sized one that only goes up to about 2 feet. That will be more than enough for us to check our dimensions and see what we can create here. That's what we double check. Anyway, we're going to aim to find an O-ring that will fit in between about 13 mil of meat. Not a great deal. Now, that's going to mean I probably want to use an 1/8 of an inch O-ring or 3.53 mil. I'm pretty certain there's not going to be one off the shelf, but we'll go and check anyway based off our dimensions. Once I've done that and confirmed that there are none, I am going to just pick the middle distance there and we will create our O-ring groove. And there's nothing, definitely nothing that will fit, because anything around that diameter is going to be a 1/4 inch O-ring anyway, which means that it's just, the groove will be too wide to fit into the available space we have. So knowing that for sure, I always check, but knowing that for sure, to go back to a smaller O-ring that will give us plenty of space to actually seal, I'm just going to make my own. So we're going to use a, as I said, 3.53 mil or 1/8 of an inch O-ring. It is a static O-ring seal here. So we've got a range of 2.7 to 2.9. So I'll usually just pick the range in the middle for your groove depth and then your groove width. What this allows for is so that when the plates are bolted together, that you have an amount for a crush, which actually creates the seal. So the depth will always be less than the thickness of the O-ring, and the groove will always be somewhat wider. Sometimes you look at the groove width and you think, geez, that's too big, but then you realize the O-ring actually squashes down to create the seal. So let's get our tool in place. We're going to pick the central distance, and then we're just going to machine it. I fully expect that this may actually ring like a bell because it is shaped like a bell, but there's not much I can do about it. We're going to use the 25mm grooving tool, which I have to jack up a little bit to fit in the Hulk. We don't have Hulk-sized grooving tools, so we'll just use a few packers here, and we'll go for it. If it does start screaming, I'm just going to turn the sound down a bit to save your ears. But yeah, let's get into it. Now that that O-ring is actually cut, I can sort of show you. You see 3.53 mil, 1/4 inch. Forgive my big fat finger. I'm trying to sort of show you here how you can see that the groove depth itself, less than the thickness of the O-ring, allows for some crush there, and you'll see that the width of the O-ring groove will also allow that when this pushes up against another plate, the O-ring will squash out, and that's what creates a nice tight seal. And because this is just water at relatively low pressure, it's going to have no problem sealing at all. All right, let's flip him over and we'll do the other side. All right, I'm not going to lie to you. I just don't want to run a steady, so I'm not going to take heavy cuts. I did consider using a SNMG internal grooving bar here and fitting it in the lathe, and then just going in and doing an internal chamfer. However, I've opted to use a WNMG bar and actually just turning the compound rest to 45 degrees so that the top slide there can use it, and I can just take little cuts and tickle out that inside groove, which is about 6 millimeters in size. So it's a bit bigger than being able to blast in there with a 45 tool. So that's how I'm going to do it. I changed my mind midway through the project. It'll take a little bit longer, but I don't want to knock it out of being true once it's dialed in.
Yeah?
Yeah. Other way,
Other way?
if you can. It's pretty freaking good. One of the quirks to working on the Hulk is you need a stool to get up and see anything on it. So the way I'm going to do this is by using the top slide here. I'm going to touch off the existing chamfer, which is a 1 mil chamfer, and then be able to cut back and forward using the top slide, and then to make sure that I can be accurate as to the size of this groove, I will use the X-axis on the cross slide. So that's the little handle down here. I will be able to wind that out. It will actually be double the dimension of 6, so it'll be 12 mil. Something that people picked up on one of my previous videos is the yerba mate. I spent a year living in South America out of school. I love this stuff. I've been drinking it for 20 years. I just tell people it's like green tea on steroids, but more delicious. And it's weird, no matter how hard I try, halfway through a job, my bench always looks like this, a bloody mess. They've also requested a larger chamfer or lead here on the front, which I'm going to make it a 20-degree lead and to make it a roughly 8mm long. It's just so that when this goes inside the swivel that it will pass over the O-rings. So we'll use a little tool to tickle that up and then the job is done. It's going to seal up lovely. That one came literally out of the lathe straight in to get fitted to site. So I'm happy with how that turned out. Everything is within tolerance. The groove depths and widths are correct, and I'm happy with the placement of them. So that is just an example of the sort of jobs that we're always throwing into the Hulk and why it saves us so much time. So anyway, if you made it this far, guys, I appreciate you. If you're new to the channel, don't forget to let me know where you're subscribing from. I always love to know where people are tuned in from around the world. And if you got something out of today's video, let me know in the comments. Anyway, guys, I will catch you in the comments and I'll catch you on the next one. We're all ready to go. Daddy's come along, they're ready to roll. Yeah, sorry buddy, but we can't go.
Buggy.
Oh no.
Hold on,
Hold on, Buggy. Oh no. Next time. Next time, Murray. Next time. Teddy, do you want to hop on? Yeah? Okay, we'll get on.
Again.
Down? What about beep beep? Beep beep? Who's making that noise? Is that Grandad?
Jimmy, I need help.
Gonna help Grandad, mate? Good job,
Really?
buddy. He's walking like you. Walk like Grandad, mate. Toys! All the toys, mate. This one's the Hulk. You wanna go play with the Hulk? Oh, wow. They're all locked out, mate, so you go for it. No, Murray. No, Murray?
Wheel.
Wheel.
Wheel. Wheel. Okay, guys.
You got it sorted, mate? Programmed up? E-stop, ready? This one's gonna go, stop.
Top.
Ready? Go, stop. Push it. Push it down. Yep. Stop. That's the way. First thing you need to know on a lathe, mate. Stop. Hey, Teddy, do you want to play some more? Yeah, okay.